Hello everyone. Today's video will demonstrate for you how to use Odot's D-Series PLC to communicate between PLCs. Odot's D-Series PLC supports the IEC 61499 standard. This standard is open and distributed. When performing communication between PLCs, we don't need, like with other PLC brands, to program communication for each PLC individually. We only need to link events and data between the two PLCs. It will implicitly create a communication function block to achieve our communication goal. In this video, I will use two DU03L PLCs. One PLC is equipped with a DT121F digital input module. The other PLC has a DT222F digital output module. The functionality I want to achieve is when I enable a certain digital input on PLC 1. At the same time, a corresponding digital output channel on PLC 2 will also be set to 1. Next, let's start programming. Odot D-Series PLC programming uses a BS architecture. No additional programming tools need to be installed on the comput. We access our server via a browser to carry out programming and development. Here, I'm using a local area network environment. After entering the interface, click on IEC 61499. We create a new project. I name it Communication Test. Click Save. After creation is successful, click on this project to enter our programming interface. Before starting programming, we need to import the device description files for our DU03L. Since I've already imported them, I won't repeat this step. How to import? You can refer to our previous videos. In the project tree, we add two PLCs. Select DU03L, configure its communication path. My two PLCs. One has the IP address 192.168.0.60. The other is 192.168.0.70. Change the port number. Click Save. Perform communication test. You can see the login is successful. Next, we continue to create a PLC named DU03L_70. Similarly, change its IP address. Change the port number. Click Save. Also perform login test. You can see both PLCs have successfully communicated. PLC IP addresses can also be checked via the built-in PLC operation panel to view. Next, we carry out programming development. Since IEC 61499 is a distributed standard, we can, within the same application, program both PLCs. Then deploy the two different programs to the respective PLCs. We return to the PLC. Delete the initial task. Create a timed task. I set it as a periodic task triggered every 50 milliseconds. Do the same change for PLC 2. Next, on both PLCs, add their respective I/O modules. Right-click the PLC. Select Add Protocol. Select our backplane communication. Continue to add my DT121F module. Do the same on PLC 2. The difference is, it requires adding the DT222F digital output module. Deploy them. Next, on both PLCs, add our backplane communication function blocks. Enable the backplane communication. I use periodic refresh to update our I/O backplane. Next, we proceed with programming. Since I want to take the digital input data from PLC1 and provide it to PLC2 as its digital output data, we add a 2-byte function block and deploy it to both PLCs. Link its events and data. Deploy the left function block to PLC1. Deploy the right function block to PLC2. You can see that between the two PLCs, the two function blocks are deployed on different PLCs, so their colors are different. Back to PLC1, assign our periodic task event to the function block. Then check PLC2. You can see its events and data all come from PLC1, so we don't need to connect events manually. Next, we bind the data to our input and output channels. Click the top right to switch to IEC addresses. Bind the data to IB0 IEC address. Click Save. At the same time, bind the output to QB0 on PLC2. Click Save. Perform deployment operation. Next, we can monitor. We use a jumper wire for a short circuit test. You can see, after the input channel on PLC1 is enabled, the output channel on PLC2 responds accordingly with output action. That concludes today's demonstration. Thank you all for watching.